first power quality phenomena to be discussed is transients. Transients are very fast events, typically lasting less than one cycle of the fundamental frequency, although some may last up to 3 cycles of the fundamental frequency. There are 2 types of transients as defined by IEEE 1159-2009, impulsive and oscillatory. An impulsive transient is a sudden non-power frequency change from the nominal condition of the voltage, current, or both that is unidirectional in polarity. This waveform illustrates an impulsive transient. As is shown, the impulsive transient's deviation from the waveform is only in one direction. In this case, out of the waveform. Lightning is one of the most common causes of impulsive transients. Due to the high frequency components present in an impulsive transient, they have a tendency to dissipate quickly due to the resistive and generally inductive nature of electrical systems. An oscillatory transient is a sudden non-power frequency change in the steady-state condition of voltage, current, or both that includes both positive and negative polarity values. This waveform illustrates an oscillatory transient. As can be seen, the oscillatory transient's deviation from the waveform has 2 polarities, that is to say, 2 directions with respect to the original waveform. Oscillatory transients are characterized by their frequency and are often the result of switching events. Energization of capacitors, drive commutation, ferroresonance, and even impulsive transients can all produce oscillatory transients. Transients are characterized by any number of traits including their peak magnitude, rise time, frequency components, duration or damping factor, and probably the most important, energy content. Transient events can originate both within an energy consumer's facility or out on the utility grid. They can disrupt equipment operation, degrade equipment components, or even cause component failure. Because transients, by definition, occur over an extremely short duration, it is important to use metering devices with high sample rates to capture transient events. Using slower sample rates on high-speed events can result in lost or inaccurate information, making troubleshooting transient issues more difficult. That's a brief discussion of transients. Back to you, Carl.
Thanks, John. Be sure to watch the whole series to learn more about power quality phenomenon. This is Carl Kersey from Carl's Corner. Be safe.